All right. So the second way to calculate enthalpy is calorimetry. We just went over how to do stoichiometry. Now this is calorimetry. The formula for calorimetry is Q equals MCAT. It's Q equals MCAT. M is what? Mass. N, the letter N as in Nancy or November, that is moles. Like in PV equals nRT, that's moles. M as in Mike is mass, okay? Or math is mass. So M is mass. C is the specific heat capacity of the substance you're looking at. It's a constant, all right? It'll either be given or you're calculating it. There's one you're going to have to memorize, but that's okay. And then delta T is your change in temperature. Just like with delta V when we did the work equation, delta T is going to be T final minus T initial. And then Q is your heat. Is it possible to have a negative Q? Yes. Because it's possible to decrease, if you decrease your temperature, you're going to have a negative Q. In order to decrease your temperature, you have to remove energy, so Q would be negative because it's exothermic. Okay, remember the sign tells us the direction of heat flow. Right, Joseph? Okay. So, in this problem, we're calculating the heat that must be added to change the temperature of 250 grams of water from 25 degrees Celsius to 60 degrees Celsius. Okay? So M is what? 250. C is, for water, 4.18 joules per gram degree Celsius. You need to memorize the specific heat of water. Okay? I'm not going to make you memorize any other specific heats, but you do need to memorize the one for water. What that means is it requires 4.18 joules of energy to raise 1 gram of water by 1 degree Celsius. Okay, next class we're going to talk more about, well, actually we might do it today. We're going to talk about comparing specific heats of substances. It's not the same for all substances. And this is the specific heat for liquid water. Solid and gas water have different specific heat. You only need to memorize the liquid water specific heat. Okay? All right, and then what is our change in temperature? Well, that's going to be 60 degrees Celsius minus 25 degrees Celsius. Because it's the final minus the initial. We're starting at 25, we're ending at 60. Okay? So go ahead and do that calculation. Is our Q going to be positive or negative? Positive, because the delta T is positive. The delta T is what's going to dictate the sign of our Q. Because you're not going to have a negative mass, because that would be impossible, and you're not going to have a negative specific heat. Because that's going to affect the temperature. If heat's being added, this is heat being added to do that. To go from 25 to 60, you have to add heat. All right. Oh, I see what you're saying. Yes. The fact that it says heat being added means it's going to be positive. But what if it didn't say that? Then you will not always have context clues from the problem. You should be able to know it from the context clues and from the calculation. Okay? So what did you get as your Q with proper sig figs? 37,000 joules. And unless it specifies, you can leave the unit in whatever you get it in. Unless it says calculate the Q in kilojoules, like you can just leave it in joules. That's fine. Okay, unless it specifically asks for a particular unit. Okay? All right. This one. So we're told that 2.09 joules of energy are required. So if that much energy is required, is it endo or exo? Endo. It required, meaning that we need to add it. Okay? This means it's endo. So that means my joules are going to be positive. To change the temperature of 15 grams of mercury by 1 degree Celsius. We're going to calculate the specific heat of mercury. So we're still using Q equals MCAT, but we're solving for C this time. So Q is positive 2.09 joules. M is what? 15.0 grams. C is what we're solving for. And while I don't have the final and initial temperatures, I know that it's changing by how much? 1 degree. I know my delta T. And I know that that's going to be positive because energy was required. If it was released, then I know that that delta T would have had to be negative. And my Q would have been negative. All right, so now it's just algebra. This is for mercury. C of mercury is 0.139. Yep, joules per gram degrees Celsius. Joules divided by grams divided by degrees Celsius. Now, I was supposed to change to pink. Pink. Oh no. I lost my little circle. I'm struggling today. All right. Let's compare that to water's specific heat. Water's specific heat was what? 4.18 joules per gram degree Celsius, significantly larger than the mercury one. Okay? Significantly larger. Specific heat is inversely proportional to how much the temperature will change. Okay, I'm going to say that in a different way. If I added the exact same amount of energy as I did with this mercury, the 2.09 joules of energy, if I added that same amount to water, water wouldn't change temperature as much because it has a higher specific heat. Specific heat is, remember, specific heat is how much energy it takes to change the temperature of a specific mass. So if it's going to require more energy, then it's going to change temperature less for the same amount of energy comparing two substances. Okay? Which is why, when's the best time to go to, like, the beach? When in the summer? In, like, August, September, July, like, later in the summer, because you've given the water all summer long to heat up. It takes a long time to heat up water and for it to cool down. It retains its heat for a while because it has such a high specific heat. Okay? All right. What time are we done here? Like in like 3 minutes? Okay. So we're going to stop there.